So a chemical reaction can also involve the change in temperature. And lastly, it can involve the evolution of a gas. Now you'll see that you take a zinc granule and you take some hydrochloric acid, HCl, and you dip this green zinc granule in this hydrochloric acid. You'll see that you should actually take this conical flask. I'll tell you why. Because you can put a cork in it and then you can take this outlet from the conical flask. So you put this zinc granule in this and see what comes out of this pipe. You'll see that a gas will come out of this pipe. And if you bring a burning matchstick near this gas, it will burn with a pop sound. And with this pop sound, you get to know that it's hydrogen gas, H2. Because zinc will react with hydrochloric acid and it will form zinc chloride and it will evolve hydrogen gas. And this hydrogen gas will come out of this tube, and then when the burning matchstick is brought near this gas, it will burn with a pop sound. So in this chemical reaction, there is an evolution of gas. So generally, these are the 4 things which tell you whether a chemical reaction has taken place or not. So there might be a direct question where you can be asked what factors determine that a chemical reaction has taken place. So you need to write down these 4 things. And they can also ask you give examples. So like I gave the examples, just give one example of each factor. Now we come to, this was about chemical reactions. Now a reaction, you need to write it down so that you can study it. So how to write it down? You cannot write that magnesium reacts with oxygen to form magnesium oxide. That is very cumbersome to write. So you have this chemical equations. Chemical equations basically describe the chemical reaction. So in chemical equations, what you do is that you write the reactants. The reactants, that means the substances which react, undergo the reaction. And you have products. That means substances formed after the reaction has taken place. So you have reactants and products. What you do, you just keep an arrow between the reactants and the products where the arrowhead points towards the product. It means that the reactants have changed into the products. And reactants, they can be many in number, so you divide them with plus signs. Like X plus Y plus Z, and gives, suppose, some A. And you can have multiple products, so it can be A plus B plus C, like this. And if you have a catalyst or something sort of a thing, a catalyst means which just helps in the fastening of the reaction. It just increases the rate of the reaction. It does not take part in the reaction. So you write that catalyst on the arrowhead. Like, heat can also be a catalyst. So this heat or something you can write, or it can be any other substance also, can write on top of the arrowhead. So this is how you write chemical equations. And while writing these chemical equations, you never write the full name of the reactant. You only write the formula. Like in our magnesium example, you have magnesium reacting with oxygen to form magnesium oxide. So this magnesium reacts with oxygen to form magnesium oxide. Reactants, products separated by plus signs, arrowhead pointing towards the product. But writing this reaction, this is incomplete. Why? Because you see that on the left hand side there are 2 oxygen atoms, and on the right hand side there is only 1 oxygen atom. Magnesium is okay, both are equal on both sides, but here there is some difference in the number of atoms of oxygen. So what you need to do is you need to balance the equations. What do you mean by balancing the equations is that making the number of atoms of each element equal on both sides. You should make the number of atoms of each element in the reactants as well as the products equal on both sides.